How's everyone doing? How's life? How's it going? Oh, spotlight's nice. Good idea.
Fake Zoom background, or is that actually your back?
Oh, sorry.
Is that your actual background, or is that a fake Zoom
Oh no,
background?
this is a fake Zoom. This is my Hobbit hole. I wish. Oh, in this real estate market, ooh, grassy lands behind me. One can dream. One day, one day I'll live in the Shire. Uh, how's it going, Danny? It's been a while.
Yeah, yeah, for sure.
Welcome, folks. I hope everyone's having a good day. We're just gonna
It's
wait a few
going
minutes
good.
while folks trickle in. Or I don't know if Christine, if you wanted to start the activity as like a
You want to,
something.
we can get started. I mean, there's more, but as people trickle in, we could. You wanna um
Yeah, should I
start with the
share the screen then? Start the
is that
slides? Okay,
okay?
yeah. I'll go ahead and do
Let's
that.
let's start with the first initial poll. Like we like to do this at the beginning for everyone. Please answer if you can. It's only gonna be for the first second, like first not second, first minute of the meeting. I apologize in advance. I'm not feeling very well, so if I'm suddenly incoherent, blame the illness, whatever illness it is. Um So yeah, so just let us know a little bit about yourselves. We like to know, what got you interested? Why are you in this workshop? If you want to, whatever you want to share with us, it would be great to get to know a little bit more about you. And then we'll get started. And our first thing lined up, but once we're done with that step, is a very fun Look It quiz. So I don't know if you're familiar with Look It or not. Look It is kind of like Kahoot, if people know Kahoot. Then it's kind of a fun, very loud game like quiz. We're just gonna ask three questions just for fun. It's really for fun. Um, and and then we'll get started. And our amazing speakers will talk about their work and talk about themselves after.
Yeah.
All right.
So I'll go ahead and share my screen as well, but I think folks can still see the question. So yeah, go ahead and still answer those. Oh, there's a question that in the Q&A, are we able to get a recording? I actually have another work meeting right now. Yeah, absolutely. So we'll be posting the recordings online. So if you can't find it, feel free to email us. But I don't know if Julia, if you want to post the link to where the recordings are in the chat. Awesome. So yeah, so as y'all filling in the poll real quick. So today's theme, yeah, thank you everyone for joining us. As Christine mentioned, we're happy to have you all here, and we're happy to have an awesome panel. So today's theme, this is the third of the workshop series, and the goal is going to be how will my research change the world? So in general, every single workshop in this series is focused on some type of interesting application of computing research and kind of what you can do with a PhD in a computing related field. So today we're going to be focusing specifically on, our panelists, they're awesome PhD students that are doing work that's kind of critical at the intersection of kind of, computing tied to some real world social impact or kind of some real world problem that we want to solve. So just real quick, a disclaimer, Christine kind of hinted at this, but this workshop is being recorded and it's going to be made available for informational and educational purposes. The CRA does not make any representation or warranties with respect to the accuracy, applicability, fitness, or completeness of the contents. The information contained in this workshop represents the views and opinions of individuals and does not necessarily represent the views or opinions of the CRA or any organizations that our speakers or participants are affiliated with. Got to get that out there. And yeah, so you all are filling out this poll, and it looks like the responses have kind of tapered off. So I guess we could probably keep going. I don't know if
I think we can end the poll. I think we have 100%
yeah, I think all the participants have done
participation. Yeah.
awesome. Cool. So yeah,
Yeah.
so just here's a brief outline of today's session. We're going to start with some short introductions of our awesome panelists, and then, or I don't know if it's of us or the panelists or both, but regardless. And then, as Christine mentioned, we're going to have that super fun activity. Then we're going to go into the flash talks that the panelists are going to be presenting. And then after the flash talks, we're going to have a moderated Q&A. We have some pre-prepared questions that we've produced in advance, but as you all are already making use of the Q&A functionality, we're also going to be taking questions from the audience. And then at the end, we're going to end with one final survey just to kind of get your feedback about how this event was, how we can improve these further events, all that good stuff. So just an introduction about the UR to PhD program. So UR to PhD, it's a program whose objective is to increase access to undergraduate research opportunities and close the gap between a student's first experience in research and a successful PhD application. And the program has a focus on women in general and gender marginalized folks. And some of the activities of the program, we have undergraduate research methods course, we have graduate student mentor training courses, and we have online workshops. And this specific workshop series is part of the program. It's a monthly 1-hour workshop series designed to help students learn more about computing research, research careers, graduate education, kind of anything that might be related to computing research and hopefully some type of like PhD level graduate research down the line for any of you. Some spring workshops include, so far we've done, what's next after doing some initial research. We've had a workshop on what does a career in computing research look like. Today is how will my research change the world? And our next session, which we'll talk about at the end of the session, is how do I combine my other interests with computing? So just to kind of introduce us, the team, we have Christine, myself, and Julia will be organizing these workshops. We're also joined by some amazing panelists. We have Danny, Alberta, and Alex, who are going to introduce themselves a little bit later once we get to the lightning talks and whatnot. Oh, actually, no, I guess we have her here. So Alberta Ansah, sorry, I should have looked at these earlier. Alberta Ansah is from University of New Hampshire. Alex Cabral is from Harvard University, and Danny Perry is from the University of California, San Diego. We're very fortunate to have these folks. Thank you for taking the time to be with us. So I guess as we get started, let's maybe start with this Book It quiz or
Okay.
challenge.
So this is kind of like a quiz slash game. So really, I mean, the theme of this talk is how does computing change the future? How does it apply to the future? So just we wanted to ask you a few questions. What do you think? Just what do you think computing research leads to? It's a very simple, short game. It's fast-paced, it's fun. It's kind of like a quiz. So feel free to either, go to playtheplugit.com and enter the game ID, or click on the link or scan the QR code. You can join using any device, like any type of device. The game is going to force you to use a random name. I'm sorry, this was like, I thought this was, a fun thing. You'll get some fun names. I'm going to wait for a few people. Wait until people join a little bit, and then I'll start the game. When the game starts, basically, we have, I think, 60 seconds to answer, or 20 seconds. I don't remember what I set it to. But 60 seconds, basically, you have a certain amount of time to answer the question. So it's kind of fast-paced. You need to quickly answer the question, and we will go round by round talking about the questions, and I'll be sharing with you what the answers were and what the stats were. Okay, so far we have a few of you joining. So far we have 9 of you joining. Okay, I'm gonna start the game. It doesn't mean that you can't join after. You definitely can join. So please, click on that link, scan the QR code. I'm gonna start the game from my side and make sure everyone is muted, because this is gonna be loud. So if you're in a shared space, just wanted to give you a heads up. This is gonna be loud. All right, so we're getting ready. All right, 20 seconds. The question here is, computing researchers in gaming can explore and impact every facet of the gaming experience from design to tech, policy, and moderation. Is that true or false? All right, so we are getting, okay, let me try, actually, you know what, I'm gonna try. Whoa, next question is jumping in. It didn't even give me a chance to share my screen and tell you who was on the leaderboard. But here's the next question. Computing research does not have a business impact. Let me share my screen here real quick so I can catch this. So the true answer here is false, and all of you got this. What, do we all know the answers to these questions? That is interesting. Here's the leaderboard. The leaderboard, by the way, it gives you more points if you do it faster. So far, Titan Forge is doing a great job. Nice job, Titan Forge. All right, last question. Which of the following is not a real type of computing? All right, now this is interesting. We got most of you saying this is a trick question. All of those options exist. And 10 and Forge ended up being second, Silver Thistle. And again, we got 27 points. Great job, everybody. I don't know if you're hearing the trumpet, but like there's a trumpet in here right now. Good job, everybody. So yeah, that was it for the game. We hope you enjoyed it. And now I guess we'll transition back to the speakers. Nima, you're
Awesome,
muted.
perfect. So yeah, thanks, folks. So yeah, we'll transition to the flash talks. I guess panelists, maybe I should remove my spotlight, or maybe we can add the person who is going to be speaking. So I guess we'll start with Alberta, and I guess just Alberta, just feel free to say like next slide whenever you're ready to transition, and I'll just kind of transition for you.
Sure. Hi, everyone. Thank you for having me. I'm Alberta. I'm a PhD candidate at the University of New Hampshire. So do I just go through my journey right now or just talk about what I do?
Yeah, maybe just some brief words about kind of what your path was to this point,
Right.
and then we can move on to the stuff that you're currently working on.
Okay, great. So I started by getting a bachelor's in computer engineering back in 2012. That was inspired by my love for electronics and a little bit of programming. In 2016, I got my bachelor's and went into a one-year teaching assistant program. And then in 2018, I went into getting a master's in electrical and computer engineering. But my research focus was in human-computer interactions, which is what I'm still doing now for my PhD, which I started in 2020. So you could go to the next slide, please. Okay, so my research is centered on the future of work, which is this umbrella project funded by the National Science Foundation. But particularly what I'm interested in is how remote workers work to support their well-being and creativity, particularly how to understand the current and future technologies that can be used to support people working from home. And that stemmed from a project where we were trying to understand how people work and live and evolve in highly automated vehicles, which we are starting to see now in on the market today. So everything that has to do with people working remotely and how we can support their well-being, their creativity, and the kind of technologies we explore to support that. Could you go to the next slide, please? Okay. So I've touched on the 3 pillars of what I'm doing right now, which is focusing on group collaborations, how these groups explore creativity and the well-being of the remote workers. We're looking at the factors that it can influence their productivity in remote meetings or in remote work. We're looking at group creativity with people we call knowledge workers, so people who work in highly skilled environments, and what kind of technologies are available to support their well-being as well. Next slide, please. Okay, so I picked this project, which is something we completed 2 years ago. This was a big project that was co-sponsored or worked with National Science Foundation and Microsoft Research, where we looked at how interruptions in remote meetings can affect group collaboration and group creativity. This was a really exciting project where we had people from different locations, different backgrounds come together to work, and we tested them on creativity measures such as their convergent thinking and divergent thinking, which is essentially how creative they are. And we tested how people who were distracted during these meetings affected the group. This was a really interesting project which involved a few undergraduates that we worked with, and I was really proud of the results that we had. Overall, we figured out that people who were distracted in meetings, which is pretty commonplace since we're all involved in remote meetings these days. I mean, we are pretty much on Zoom right now, are often multitasking. So people are checking their phones, they're checking their emails, and that's something that we've come to live with. But the question becomes, how do we make sure that these people in these groups are actually doing something productive and how does it help the group as a whole. And so the results showed that creativity in a group can be affected by the distracted persons. Also, interestingly, some distracted people can find a way to manage their time and balance their attention in order to contribute to the group in a meaningful way. We also found some indications of distractions, which included people looking away from the screen, people looking down intermittently, which was really interesting insights that could affect designs for future technologies that affect remote meetings. So that is it. Thank you.
Awesome. Thank you so much for sharing with us. Oh, that's super relevant. And like, yeah, I mean, it's interesting that you mentioned this, given that we're all in a Zoom meeting right now. So this is amazing work. Yeah, thank you so much for sharing.
Thank you.
Thank you. So the next presenter is Alex Cabral, who is at Harvard University. And yeah, same deal. Feel free to just let me know when you want me to move to the next slide, and I can move you forward.
Sure. Great. Thank you. Hi, everyone. My name's Alex. So I've had a kind of roundabout path to getting to a PhD. In 2012, I actually graduated from college. And in my last semester before graduating, I did some undergrad research, which I'm happy to chat about more later. And even though I had fun, I decided when I graduated, I never wanted to go to school again. I just wanted to go make money. And so following up on an internship I'd had after my junior year, I went to Microsoft and I worked in the Xbox division, which was pretty fun. I got to play video games in my free time. But after some time, I got a little antsy, I guess you can say. I started volunteering with a program that Microsoft sponsors to teach computer science in the morning before work. And I decided after a few months, I liked that a lot better than my real job. So I quit and I left to be a middle and high school computer science, math, and robotics teacher. And I enjoyed that as well, but I realized I don't necessarily like kids or especially teenagers. And so, I had a thought that I wanted to have a bit different of a challenge, not just getting kids to be quiet. And so, I thought, I'm about to be 30 at the time. And if I'm ever going to do it, now's the time to do a PhD. And so I applied, and now I'm in my final semester. So I'll be graduating next month from Harvard. So you can go to the next slide. And so the big inspiration behind my research, I look into other things, but it's mostly around urban air pollution. And so, currently more than half of the world lives in cities, and within 20 years, it's going to be close to 2/3 of the population. So it's billions of people who live in cities. And in many cities around the world, even some places in the US, people are exposed to poor air quality. And the greatest offender that most people look into is called particulate matter, which are really tiny particles from like sand, increasingly from wildfire smoke. And to give you a sense, it's 1/30th the width of a human hair. So that's sort of what that image is showing. And of course, this leads to asthma. It can lead to premature mortality. And the big issue in measuring this is that things like EPA monitors in the US are very sparse. So in Boston, where I live, there's one actually in the city, and I think another couple outside of the city. So you can go to the next slide. And so some of the research questions that I've looked into this, one is how can we actually have low-cost sensors to provide credible and actionable data? And so for nearly 2 years, I worked with Microsoft Research on this project called Eclipse. We made these sensors from scratch with a lot of gas sensors, which didn't work so great, but with a particulate matter sensor as well. You can go to the next slide. We put these devices up around Chicago. And another question that came up there is how do we actually make partnerships to make this equitable? And of course, we can go into a whole spiral about what equitable actually means, but I think we can all agree that we at least don't want things to be unequal or knowingly unequal. And so for this, I spent a lot of time working with local community groups, particularly environmental justice groups in Chicago, with city agencies, which was pretty crazy. Chicago is a notoriously corrupt is a rude word, but I can't think of another word right now, so we'll just go with corrupt city. So there were lots of loopholes to go through. And even in Boston, I've actually had the opportunity to work with some communities and cities, and it's a lot of work and it takes a lot of time, but it is exciting. And on the bottom, I made sure to note that I actually did have a paper out of this. And so there is, real world work you can do that can result in published research. You can go to the next slide. Another question, and this is actually a lot of what I look at in my thesis now, is where do we actually put these sensors? And so in Chicago, we had 115 of them, and how do you actually decide where to put them? And so, of course, we have this idea of we want to know what's going on across the whole city. We also want to make sure that communities that are most affected are getting readings that are useful to them. And we want to make sure that we're working with the city and the different agencies to get the data that they want. And so we used one particular method in my thesis. I've been looking at all different sorts of questions on how we might do this better or at least differently. And again, this was, publishable research. Next slide. And then, of course, because these are low-cost sensors, how do we actually make sure they're reliable? And so this is a whole other set of work that I've done, which involves field work. So actually going out to Chicago, putting devices at EPA monitors. So that picture shows an EPA monitor with our sensor there. And then, of course, a lot of machine learning and data processing to make this work. So that's a whole other, micro area of research that I've looked into, and again, that I'm happy to chat about. Next slide. And then, of course, once you actually have all these data, how do you get people to engage with it? And so you can imagine that people have maps, of course, that show what the air quality looks like. You may have even looked at this in your area before if there's wildfires or something. With Microsoft, we had this really crazy vision to take a repurposed horse trailer and turn it into an interactive exhibit that we drove out to Chicago, and we had screens and we brought it to the Field Museum and different community events that were going on. And so, there's also like really, I don't want to say crazy, let's say like unique sort of exploratory things that you can look at in research, right? Where you're really building something from the ground up and then seeing how people interact with it. And again, this is published research. You can go to the next slide. And so finally, contributions, just to give you a sense of like the sort of contributions that I think I've made in my time as a PhD student. I led a deployment for all these sensors in Chicago. We produced credible data. We actually had really great press about it. Well, I guess it's not great press when it's about bad air quality, but we actually had journalists using our data and getting front page news stories about it. I've been spending a lot of time really critically thinking about where sensors should be placed, and then hopefully, discovering challenges and opportunities for people like you guys to then pick this up if you're interested and help make sure that we get more of these sensor networks out in cities in the future to help people and to help their health. So thank you. That is my research.
Awesome. Wow, that's so amazing. I mean, I love the multi-dimensions of this problem where you're kind of tackling the hardware side of things. How do we even get these devices? You have the kind of data analysis side of things. The cost aspect, I feel like a lot of computing research focuses just on like, theoretically, we could do this stuff, but you're actually deploying it in practice. That's amazing. Thank you so much for sharing with us.
Yeah, of course. Thank you.
Awesome. And then our last speaker is Danny Perry, who's at University of California, San Diego. And she will be teaching us about how our laptops see our microbiomes. And I hope there's plenty more poop emojis. That's what we always need with gut microbiome stuff. I don't know if Danny, are you still with us? Hopefully.
Yeah. Hi. Sorry.
Oh, there we
It's
go.
kind of I hope you guys can hear me better than I can hear you. And yeah, I'm actually on UCSD's Wi-Fi right now, so it's a little bit, I don't know, I guess it's a little bit choppy.
Oh, I've been there. I feel your pain. Oh, UCSD Wi-Fi.
Okay. Hopefully, yeah. And
I think it might have cut out again. I don't know if. Oh yeah, it seems like it cut out again. So maybe, I guess she's still here. I don't know if she can hear me, but so I guess for now, let's maybe move to the panel discussion, and then once Danny's internet stabilizes, we can come back to her presentation. Sorry, folks.
hi, sorry about that.
Oh, you're back. Oh,
Is
perfect.
that yeah. My bad.
No, you're good. You're good. Awesome. Yeah. I mean,
Okay,
if it's
cool.
working, yeah, go for it.
Sweet. Okay, so hi guys, my name's Danny Perry, and I'm going to talk to you a little bit today about, like why I decided to do my PhD, and then a little bit more about my research, which is quite literally how our laptops see our microbiomes. So I always kind of had like this interest in genetics growing up, just because like I have a pretty diverse family background. My grandma is actually from Guatemala, and there's a lot of like super rich ancestral stuff that I learned about my family, like through genetics. But as it turned out, like about 6 months before I started seriously applying to grad school, I discovered, I read this book on the microbiome and it totally changed everything. So all of this really cool stuff I'm doing in my life to prepare for like doing like population genetics and stuff, actually, I completely switched not completely switched fields, but kind of like decided to move away from what I was doing. So I was like, yes, um, summer in Maine, working at the mouse genome data, and it was extremely fun, and it made me love research. So then I moved from college, TSF, and then it really I liked the lab, and the next career decision was to just do a PhD. And I really liked my job there, and I have really enjoyed like transition into the PhD life, and for studying the microbiome. There's a lot of really cool people at UCM, so I've had a really fun time. Next slide. So you might have heard about the microbiome. It's kind of like a buzzword these days. The actual definition is this collection of microorganisms that inhabit a particular environment. And so in my case, it's kind of like, the organisms that live on and around your gut, on your skin. It can influence a lot of things like even your mental health. There's about a 1-to-1 ratio between like bacteria that live on and around your body and your human cells, which is pretty huge. And there's also about 10 times as much bacterial genetic material in our bodies. So, we're studying genetics and we're ignoring like all of that. That's just not that's not a great strategy. So we need to understand these bacteria and what's going on with their genes. It's been associated with diseases that make a lot of sense, such as like irritable bowel disease, obesity, cancer, and allergies. And now we're finding that it really affects a lot of things that we wouldn't normally think about, such as like mental health disorders and stuff like that. And one of the things that makes the microbiome tricky to study is that it varies from person to person. So you could have a perfectly healthy microbiome, and I could have a perfectly healthy microbiome, but since our diets are so different, those will look completely different. And so we don't really know how to tease apart healthy and diseased microbiomes. Next slide. So how do we even begin to do this? Basically, what we do is we collect a sample. In this case, we're talking about studying our gut microbiome. So let's just say we collect a fecal sample, we extract all of the genetic information, and we sequence it, and we map it back, and we get this table that looks kind of like, we have all of our samples and all of our species. And then we also have a little bit of information about these samples that we can use along with this information that we get from the microbiome data. However, there's a lot of things that make this super hard to do. First of all of our features, which in this case are like the species, are actually dependent on one another. And so you guys have probably like maybe seen these like phylogeny trees that kind of relate evolutionarily how these species are related to each other, which makes total sense because like two bacteria could be very similar and could be accomplishing the same goal, and one could be very different. And so if you have these bacteria in different abundances in your gut, it will differ closely or farly related these species are. Second of all, the data is typically like compositional, which just means that you get like, oh, this percentage of the bacteria in your gut belongs to one species and this percentage is another, which adds another layer of dependency between your features. It's very it's very high dimensionality, so you are frequently looking at like thousands or tens of thousands of species. And then this is going to be a very sparse matrix, which means that very few people have very microbes, and many microbes are unique to some people. And so it's really important that we develop like new ways of studying this and new ways of making this data a lot more interpretable. And so processing data is actually very important for a lot of reasons. One story that I like to tell is one time they were doing a study based on, and they're trying to look at what defines like sort of the environment that you work in, an inside environment versus an outside environment. So they took a bunch of samples from inside buildings. This is UCSD, this is Scripps. They took a bunch of samples out here off the pier, and then they took a bunch of samples inside. And due to poor bioinformatic processing, they determined that the main difference between the inside versus outside environment was the presence of like chimpanzee DNA, which is obviously like so corrupted in so many ways. Like the sample was obviously, the sample was contaminated with some human DNA, which unfortunately like incorrectly mapped back to a chimpanzee. So that study was botched in a lot of different ways, and I am trying to develop tools to make sure that stuff like that doesn't happen. You can go ahead and go on to the next slide. Yeah, there's the chimpanzee. So one method that me and some colleagues have come up with to dealing with all of these different data layers and sort of the intricate dependencies between them is by using this modeling system based on Haar wavelets. And I'm going to get into, I'm not going to go too far into detail about what these are, but basically they allow us to represent these so-called phylogeny trees, or these matrices that relate one of your features to another in very clever ways that allow us to do really fast and scalable data processing. We're able to answer questions with larger amounts of data much faster than we ever were able to before using this tool. One of the most recent things that I've been working on, you can go ahead and go to the next slide, is how we're able to identify exact groups of species that are distinguishing groups of people from one another. And so in this case, we're looking at the difference between the microbiomes of infants in the Western civilization, like in the United States, and babies in African environments, in rural African like places, and we can specifically map the differences in their microbiomes back to this one order of bacteria and specific group of bacteria that belong to this order of bacteria. And so when you compare one sample to another, the ratios are present in very different quantities, which we know for a fact is driving these differences between populations. So overall, like some of our future studies are going to be applying this method to try to see how the differences between like healthy and diseased individuals. And one really exciting study is we're looking at how a probiotic could be used to prevent death in infants and populations. And so some of this work on like probiotics and like incorporating diseased versus healthy individuals has allowed me to, you know, go to some super cool places. I went to this pediatrics conference in Hawaii last year. That was super fun. And then on the left is me presenting at a conference here in San Diego. And so, yeah, I really like the research that I do, and it's been a super fun time. So thanks for listening.
Awesome. Yeah, thank you so much for sharing. Oh, super exciting stuff. And just it's wild to me how much of just random health features have to depend on your gut microbiome. So it's awesome that you're kind of deciphering those secrets and looking up for potential therapeutics and whatnot. Yeah, thank you for sharing. Cool. So that was our panelist presentations, and now we're going to kind of transition to the Q&A section. You all got to hear not only cool stuff about what all the folks are doing, you know, in their research, but you also got to hear some stories about how they got to where they are, what decisions they made throughout their lives. So I'm going to just stop sharing my screen, and I'm going to go ahead and put everybody on the panel as a spotlight for everyone, and we will go ahead and start the panel questions. Let me just make sure that everybody can see everybody. Awesome. So as I mentioned earlier, we have some pre-prepared questions. I'm going to ask these just kind of generally to the entire panel. Feel free to jump in as desired. Feel free to raise your hand if you want, and I can kind of help call on people to make it a little bit easier. And no pressure to answer every question, especially if there's any questions you don't feel comfortable sharing. No pressure at all. But I guess the first question I'll ask is, what got you interested in this application area of computer research? So you're all tackling very, very different real world problems, all extremely important. How did you initially get interested in the problem that you're tackling? I don't know if anyone wants to go first.
I think I have a pretty easy answer. I really wanted to do science and answer these fascinating questions, but I just never had the patience for doing wet lab research. So, and was initially good at math in high school. So that's kind of how I ended up here.
Yeah, thank you. And then, yeah, Alex, please go for it.
Yeah, so for me, when I started grad school, I didn't really know what I wanted to do. And I actually ended up switching advisors. And I know everyone has quite a different experience. Sometimes people get hired on for particular projects. For me, my initial advisor was like, oh, just kind of figure it out. And he had a great idea, which was to put together a reading group based on things that I was interested in. And so I had a few people from the lab and a few people I had met in classes who would come every week. I would find a reading, and essentially what I found through that semester in the reading group was that I was really interested in the intersection of sustainability, social justice, and civic engagement. And so where I landed in all of that was this idea of environmental justice, where, you're working with people who have obviously these issues around sustainability, around social justice, and then getting people engaged in their local areas. So I think reading overall just helps a lot, and getting you to think about what you're interested in. And it doesn't even have to be reading research papers, like reading books, reading news articles, anything that you find that piques your interest. You can kind of set that aside and recognize that that might be what interests you to go through several years of a PhD.
Yeah, thank you for sharing. And then, no pressure, Alberta, but feel free if you want to also.
Yeah, so for me, figuring out what I wanted to do in grad school kind of started with the internships I had during my undergraduate studies. So even though I had my undergraduate studies in computer engineering, I did some internships in software design in companies, and I did my internships in an automation company where I did hardcore hardware things. And at the end of it all, I figured out I don't want to be a software engineer. I don't want to do coding. That life was not for me. I also didn't really want to be a full hardware engineer. And so when I discovered HCI, it was like a light bulb went off, and I noticed, okay, this is where I belong, because it's a little bit of everything. I've been blessed to work with people from different fields. I've worked with psychologists, I've worked with human factors engineers, and it's a very collaborative space, which allows me to learn from different fields. With my current research, it was kind of born out of COVID, because when COVID hit, everyone was working from home. And the initial funding was about remote work, or the future of work, but it was mostly focused on autonomous vehicles. So how will people work in the future, where you have fully self-driving cars, if you will? And then COVID hit, and we were not able to be in the lab to run studies, and everyone was working from home. So we pivoted to that, and I think that has been one of the most interesting journeys for me, because there's real value in understanding how people can work from home, because it affords so many different groups of people the opportunity to work and collaborate. And so that's kind of how I landed there.
Awesome. Thank you so much, all of you, for sharing. It's really exciting. Yeah, thank you, folks. So I guess that's what got you to your current research topic. And I mean, in all of your presentations, you gave us context of how the field looked like before, and then you showed us what your contributions are. I guess my next question is a little bit more forward thinking. So you're all doing this amazing work right now. How do you imagine the world is going to look like in the next, maybe 10 years, based on the results of the type of research you're working on? it gonna look different or the same, or I guess how so? Hopefully different. Hopefully I'll make you yeah, Alberta, please go for it.
Yeah, so I think even though we're sort of back to normal, I mean, COVID was now what, 4 years ago, and people are working back in offices. Remote work is pretty much going to be a part of our lives, I think, moving forward, because we found the value in it. And again, it's not just about work, it's about remote conferences and allowing people from diverse backgrounds to come together to work. And so really understanding beyond the platforms like Zoom or Teams is understanding how people can actually contribute as a group, understanding how they can be productive, and also how to support their well-being. And that's something I see will be useful for the next 10, 20 years. And this also has real value for the initial projects, which was working in autonomous vehicles. In the maybe not too distant future, we're going to have more advanced cars, more advanced vehicles that would allow the driver to have much more time on their hands to do other things outside of driving, because the automation is taking care of it. And so how are we going to use that time when you're going from point A to point B, still be productive, still have perhaps a relaxing nap? Who knows what the future holds? And so this is definitely going to have an impact in the next few years.
Ooh, that's super exciting. Oh, I can't wait for that road trip, just hands off, enjoy myself. That sounds awesome.
Yep.
I don't know if Alex or Danny, if either of you two, no pressure, but just wanted to open the floor.
Yeah, it's really hard to tell. I think like the main advancements in this space are like being able to deal with more data. And so hopefully like research will progress in that area, and so you'll be able to make more powerful predictions, make better use of more data.
Awesome. Yeah, that makes sense. Yeah, kind of like demystify. We have this like explosion of data right now. So, having a better understanding of it 10 years from now, how does that actually work? That makes a lot of sense.
Yeah, exactly. And then the impact of that is like,
Yeah,
in the medical
diagnostics.
space.
Mhm.
Yeah, in the medical space, it's obviously like, oh my God, we want to save lives. Use big data to save lives. Like that's what everybody wants to do.
Absolutely, yeah, the dream.
Hopefully that starts happening. Yeah.
Awesome. Yeah,
Yeah,
please
for
go
me,
for it.
I think the biggest thing would be that I hope that we'll start to see more sensors around cities, and this idea of smart cities will actually start to come to fruition, especially in the US. I know that some European cities have gotten a bit further along. So yeah, that would be my real hope, is that we really start to see it, or that we at least start to see, communities that are using devices such as purple airs be able to figure out how to use them better, to actually gather data that are actionable, so that they can go to lawmakers, or they can take these data to court and actually get meaningful changes in their lives.
Awesome. Yeah, thank you. That would be great. Absolutely. So my next question, it's a little bit different. It's not going to be about your research areas, but you three are the only panel we have so far, and potentially of the entire series, that's all PhD students. And I think a lot of the attendance, in the audience, I think there are a lot of undergrads that are interested in pursuing a PhD potentially down the line. So I guess maybe one question that I'm sure is on all their minds is just, what does a day look like in the life of a PhD student? What do you do? Are you coding all day? Are you in meetings all day? Just kind of like, what does that look like for you?
It's definitely a mix. It's definitely a mix, but you kind of nailed it, Nima. A lot of it is like coding. Um, like the main thing is like my favorite part about doing a PhD is the flexibility it allows you. You know, like I like kind of worked in corporate for a while, and it's like, if you're not a 9 to 5 person, then like that's too bad and you have to just deal with it. But as long as you're getting your work done, you can kind of do anything whenever. At least like I think a lot of groups are like that. Not all of them are. I know for a fact that yeah, for sure. But so I think like a day in a life is like you just, whatever work you need to get done, you get done. as much as you can. You know, you have lab meeting once a week. Again, that's just for me, a couple of like project specific meetings. I personally like don't feel completely drowned by meetings. It's sort of like when you're new, you're learning the ropes and people understand that. And then as you like progress through your PhD, I feel like more people are putting more responsibility on you and you get like roped into more projects, I think. And so things definitely get busier as you progress. But like I think you're kind of able, if you have a lot to accomplish, you're kind of able to accomplish in whichever way suits you best. So yeah, I hope that's like helpful.
Yeah, absolutely. Awesome. Yeah, thank you for sharing. Yeah, I don't know if Alberta or Alex, any thoughts?
Sure,
No
I
pressure.
could
Yeah.
go. So I think it changes from day to day, different projects, but for instance, in my current project, I just completed my data collection phase. I was running user studies, which was at Wolsey College. So I'm working with undergrads there in their HCI lab. So currently, since I kind of wrapped up the data collection phase, now there's a lot more coding because I'm analyzing the data, I'm cleaning the data, making sense of it all, which is pretty much what I do all day. And then there are the occasional meetings. If you're working on multiple projects, then you're working with different teams like I am, because I'm in a very collaborative space. I work with researchers from different places, so I meet them online to discuss research questions. I think early on, you would do a lot of literature review, which is really key in PhD life. Like you can never stop reading papers, which is like a part of it all. So you have to get used to reading research material, which can be a little daunting in the beginning, but once you get the hang of it, know how to read the abstracts, you know, the results, procedures, you get the hang of it, and it gets easier from there. At least I hope it does.
Awesome. Yeah, thank you so much for sharing. And yeah, Alex, please go for it.
Yeah, sure. Yeah, I think Alberta and Danielle kind of nailed it. It definitely goes through phases. You have like your phase where you're reading a lot every day. You have your phase where you're writing a lot every day. Something I try to do is read and write a little every day. Now, because I'm very close to finishing, I'm doing a lot more writing, and the reading I'm doing is reading my own writing, which is a bit much. But I think, you know, especially early on, it is a lot of reading, but also a lot of like even just taking notes about what you read is useful. And then, of course, you know, there's, in my case, I spent days doing field work or designing experiments for others to help me do field work. But I do think there are phases. And the great thing, like Daniela said, is that you do have a bit of flexibility. And so especially if, you know, you have a family or if you have like a disability or something that makes it so that you can't necessarily, you know, work maybe traditional hours that other people would keep, because you have that flexibility and because there are always more things to read or to write, you can kind of figure out what works for you in your schedule. And I will say the one thing that no one touched on really is like paper deadlines. That's probably when things change a bit. And so, of course, to publish research, you have to make some deadlines. And so that might be, you know, you might be writing a bit more before a deadline or waiting for someone's comments before your deadline. But in general, like compared to undergrad, where it's like, oh, it's spring break now, there's no spring break. It's more just like, oh, I submitted my paper, so maybe I'll like take a few days off.
Awesome. Thank you for sharing. We should get shirts of that PhD.
Yeah.
There is no spring break. Actually. Yeah, absolutely.
I love that. And I don't know if you've noticed, like if people have noticed the faces of everyone on the video when we talked about paper deadlines, everyone was like, oh yeah, paper deadlines. It's like, yes, that's a whole other, like suddenly your schedule is just whatever you typically do kind of switches to something else. I love that. That was awesome. So there we have a question in the Q&A that kind of links to Daniela, what you said. It actually came as you were talking. And also it kind of touches also with the other panelists, like your path through this. The question is, how are you able to decide that a PhD was the best step for you over the 9 to 5? Like, what is it that took you from that 9 to 5 job to PhD? Or maybe not directly that way, but how'd you find out that 9 to 5 is not for you and that PhD is a good option?
Yeah, I'll go. So I think one thing, especially being a software engineer, coming straight out of college to being a software engineer was quite a shock for me, because you learn, at least doing a computer science undergrad, the things that I learned were not how to write production level code for a company like Microsoft, Google, et cetera. And so when of course I learned, and that was great, but like going through a code review, for example, when everyone reads through your code and says, oh, you should do this way, or if anyone's ever watched that show Silicon Valley, oh, we use spaces instead of tabs, something like that is real. And I think I realized after a few years that that just wasn't necessarily the sort of environment that I wanted to be in. Like, I like having a bit more autonomy over what I do rather than being told. And even, the bigger the company, the more often you'll get reorged, for example. And so, working on one project one day and then all of a sudden working on another project the next day. I will say there's trade-offs though. I made a lot of money. I had great benefits. I have friends who stayed there and own 2 houses. And so that part I think was nice. But for me, I cared a lot more about the problems that I was solving and having that autonomy in my life. And at the end of the day, I worked on Xbox, which was super cool. So many people were like, that's so awesome. I play Xbox and games. But at the end of the day, it was like, well, I work on a video game console. And yes, that is a great way to entertain yourself. But it didn't, I don't know, for me, I guess it just didn't have the sort of impact that I had been looking for. So I think those are the main reasons, at least for me.
Awesome. Thank you for sharing.
Thank you.
Makes a lot of sense.
Yeah, I definitely agree with that. Like I thought when I worked in like banking for a while, and like when I worked there, I just didn't think that it was like exactly what Alex was saying. Like it wasn't the impact that it had in mind for like the application of like what my skill set in life. And yeah, I mentioned this before, like the flexibility is great. That makes me like happy that I chose this path. Something that I kind of got into during my PhD that I am really happy about that I didn't realize I liked is teaching. I got to teach a lot during my PhD, and I never really thought that that was something that I would do. But I'm really happy that I did. And so there's just like, I feel like there's a million things you can do with a PhD in this area, and you really have like so much opportunity to do whatever you want afterwards, that it's like, why wouldn't you? Like the world is your oyster after you finish. And like I don't know, if I wanted to go back to that job, I probably would be able to. And so, but then I open up this whole world of other opportunities. So I think for me, my favorite part is like being able to choose exactly like what you want to do, who you want to work with, your type of environment. Like you can be pretty picky if you do a PhD in choosing like what type of work you want to do afterwards.
Awesome. Yeah, thank you for sharing. Yeah, Alberta, please go.
Yeah, I think my path is slightly different because I kind of stayed in academia throughout. So I did my undergrad, spent 1 year being a teaching assistant, and then went into my master's. But I knew I wanted to do a PhD. I just didn't know I was going to do it right after my master's. So when I finished my master's, I had the opportunity and I really liked the research I was doing. So when I got the funding and the opportunity to continue, I just continued along. But I think one of the main things that made me stay was the fact that I liked the environments that I was working in. I liked the people I was working with, and I liked the fact that I was making meaningful connections. So working with people in so many different countries, working with people in different institutions really broadened my horizon of what HCI could be, and the kind of impact we were making with the projects that we were working on really inspired me to like stay in this very long journey, which is almost over.
Home stretch, you got this. You got this. Awesome. Thanks, folks. So we're almost at time. I just wanted to like have one closing question, and we'll have like one final activity when we're closing. But My last question, everyone, this one, feel free to keep it just a short, one sentence summary. And no pressure if this is a touchy question, but I guess I'm really curious, like, what's next? So what are you interested in doing post PhD? And if you haven't thought about it, okay, no pressure. But just for anyone who's willing to share, kind of maybe one sentence, like, what are you hoping to do after your PhD?
Yeah, I'll go because I'm probably closest to finishing. So my plan is to do a postdoc. Assuming all the paperwork goes through, I'll be doing a postdoc at Georgia Tech with a lab group that works on sensors, energy harvesting, so a lot of similar stuff. But rather than working on urban sensors and mostly air pollution, I'm going to be working in pretty rural areas. So with Native Americans, indigenous groups in the Great Lakes, and we're trying to make sensors that can do all sorts of things around wild rice and why that's diminishing. So yeah, I'm really excited. Should be a lot of fun, a lot of the same but different stuff. And then after that, I hope to be a professor.
Awesome. Yeah, thank you for sharing. Good luck / congrats. That's exciting.
Thank you.
So I'm finishing my PhD this year, hopefully. And my hope is to do research, to continue research in kind of fields, whether it's academia or in industry. But I kind of thinking more of industry since I haven't really done full industry work.
Awesome. Yeah, that makes a lot of sense. Yeah, good luck. Ooh, that's exciting.
Yeah.
Danny, any thoughts or no pressure?
Yeah, no, I have about, this is definitely subject to change, but I have about 2 years left in my PhD. And so there's actually quite a few like small startups that have spun out of my lab. And one that's super interesting is they do a lot of like soil consulting for farmers in California to help them figure out what's going on with their soil, to improve like sort of the environment that their like livestock live in. And I think doing something like that could be super fun. And apparently you get to travel a bunch to a bunch of farms in California. So that seems interesting.
Oh, that's super cool. That's super cool. Awesome. Yeah, thanks, folks, for sharing.
Yeah,
So we have
it's,
like a, oh yeah, sorry.
oh no.
Yeah, but so we're pretty much at time. Thank you to all the panelists for taking the time to speak with us. We have a couple activities just to end things out. But just first, let's all give a round of applause to the panelists. That was excellent, and I think we're all a lot smarter after hearing all the cool stuff you
Thank
all are
you.
working on. Yeah, thanks, folks. So real quick, just to close up, let me share my screen. So first things first, mark your calendars. We're going to have another one of these on May 6th. The focus of that session is going to be how do I combine my other interests with computing? So if you have some hobbies that you want to intersect with computing, any other interests, May 6th, mark your calendar. We'll be doing all of the same, email blasts and stuff that you heard about this one through. And then also when you end the Zoom call, there's going to be a survey that fills up. So feel free to fill that out. But just real quick, as folks are heading out, let me share our final activity. There we go. Hopefully folks can see. So I just wanted to do a word cloud. Now that you've heard about all this cool stuff that all these folks are working on, what are some real world problems that you want to solve with computing? So, we've heard cool stuff about air quality, microbiome, making people more efficient during Zoom meetings and kind of autonomous activity. There's a link that I'll post in the chat that takes you directly to this poll. It's a word cloud. Just feel free to type in some words of like, what are some real world problems that you want to tackle with computing? Education, gaming, very cool, very cool. And folks, feel free to head out once you finish, but I'm curious to see what everyone's working on. So we got education and gaming. Any other real world problems people want to tackle? No, maybe it's just education and gaming. It's all good too. I'll post the link again just in case. Oh, that's okay. We'll stick with education and gaming.
They're two excellent problems.
Yeah, those are important problems as well. Well, cool. Thank you so much, everybody, for joining us. This was a lot of fun. And yeah, hopefully we'll see you all next month. Awesome.
Thank you so much. And thank you so much, Paz. Thank you so much for joining us today, and with wishing you best of luck with the, finishing up your PhD.
Yeah, good luck with the home stretch, folks.
Thanks so much.
All right, thank you.
Yeah, nice meeting you all.
Thank you.
Ciao.
Same here.
Thank you. Thanks, everyone.